We need a slogan like, stay alive at 2.5.
Oh, Jesus Christ.
There's a lot to do for 2.2. Or, f*** me, we're headed for 3.
That's it.
And my friend Andrew says, is there any way of if climate change happens soon?
No.
No.
However,
Are we really totally cooked?
I'm sure everyone wants me to say no.
Bum, bum, bum.
I'm Sarah Perkins-Kirkpatrick,
I'm Iain Strachan,
and this is Totally Cooked.
the Climate and Weather Podcast. Did COVID-19 help to repair the hole in the ozone layer?
And is it too late to save the world from catastrophic climate change?
These are just some of the many questions we received from you.
So let's open up the mailbag and get to work setting the record straight.
Let's answer some of them.
Let's do it.
We have some suggested questions here from our colleague Alex, who is a PhD student at Monash and who used to be a teacher in Tassie. Alex may not have been surprised by this because she was a teacher. I think we were a bit surprised to hear from a fairly young group of high school students some questions that we thought maybe that cohort or that generation were already across. For example, what's the difference between climate and weather?
Yeah, I think this is a really good one. And I would say that it's not just, this younger cohort that asks this. I get asked this a lot. And I think some of the questions that are following today allude from this misunderstanding. Basically, weather is what we get on a day-to-day basis and climate is what we expect. Okay, so we know, for example, what the climate of Sydney is during winter and spring, and that's a little bit different to the climate, well, it's very different actually to the climate of Darwin. Okay, so it's what we expect in that particular location. Now, weather and climate aren't completely separated. We tend to average the weather conditions to understand the climate of a location. And we typically look at that at bare minimum 20 years, but often 30, 40, 50, multiple decades or more if we can. And that gives us an understanding of what we expect on average. But what we expect on average and what we actually get can be super varied. So in one location, you can have like days where it's, very, very, very hot, as well as days that are very, very, very cold, rainy, dry, etc. And that's the weather. What happens on the daily and weekly timescale is weather. But what we kind of generally expect to happen at that location, that's the climate.
So within the centre, I've heard this phrase, climate is what you expect, weather is what you get.
Yeah.
And that phrase has been attributed to Mark Twain.
Oh, that's right. Did he really say that?
Well, that's just it. There's no particular evidence that he said it. But when you have these pithy turns of phrase, the internet likes to suggest that someone said it.
Yeah.
But I actually am going to go out on a limb here and say that I don't like that phrasing.
Okay.
I prefer, someone else said to me that climate is the average of weather.
It is. Well, that's exactly right. Yeah, we can't understand the climate unless we average the weather together. That's also incredibly true.
Because when someone says to me, climate is what you expect, but weather is what you get, for some reason in my head, I'm thinking of a major disparity there. Like, we expect 35-degree day in the Barossa Valley in February, but we get a snowstorm. And it's like, that doesn't happen. It's like...
Yeah, okay.
I don't know if that's just me, but it implies there's scope for a huge disparity there. Whereas I like the idea of climate being the average of weather, because it's like, what is the weather like in this place usually? Definitely.
You can't have the climate unless we average the weather together. That's what tells us. The weather is like, I guess, the bottom line. That's how we get to our climate. But the climate's much more of a general, like, we do expect heat waves in this location of a certain temperature. We do expect tropical cyclones in this location at this time of year. It doesn't necessarily mean one will definitely occur this season, but we do expect that to happen. That's, I guess, endemic to that local climate there.
And so building on this issue, let's look at something a bit more specific, which is the concept that when we have a very hot day or a very cold day, some people attribute that to climate change.
Yeah, This can be really tricky and also really confusing for people, and I fully understand that. Within any climate, whether it's the climate over Sydney or Darwin or the UK or whatever, there will be extremes, right? You can have very hot days versus very cold days, very wet days versus very dry days, and so on and so forth. Firstly, though, what defines the extremes is local to that climate. So a heat wave in in Hobart will be very different to a heat wave in Brisbane, for example, because of that local climate. But secondly, like extremes are part of that baseline climate. They're very rare by their definition, so we don't experience them often, and they're usually very intense one way or another. But they do occur even in the absence of climate change. So most of the time, climate scientists are actual scientists like myself, we don't rush to say that all extreme rainfall events are determined by climate change, but we do expect some form of extreme. So just because we have an extreme event, it doesn't always mean that there's a very obvious link with climate change. There would be some sort of influence these days, but we can't say that cold air event or that, really intense tropical cyclone was due to climate change, because generally speaking, if it's part of that, what we expect for that climate, there's an essence of it occurring naturally anyway.
Is it helpful to think about what might have occurred in pre-industrial times versus now? And so taking as an example, an area that I'm very familiar with, which is the UK. In 1695, in July, you might have had like a 30-degree day, and everyone would have been like, goodness me, it's so hot today. And in 2025, you might have a 35-degree day in that area. And so it's normal for sometimes in Northern Europe for there to be very hot days.
Yeah.
But because the global average temperature is rising, what is a very hot day now is hotter than it would have been 400 years ago or 300 years ago.
Exactly. So when we look at climate change as climate scientists, that's what we're looking at. How do the extreme events of today compare to the extreme events of the past? And that is hard for, us and people younger than us to maybe conceptualize, because our baseline is different to the baseline of the pre-industrial climate or climate before, 50 years ago, really, because it's already been a bit warmer.
Very early in the episode to get in the DeLorean, but we've managed it without realizing.
We have, haven't we?
Pitching up at like Chatsworth House or something. And,
yes.
Isaac Newton's there in the garden sweating and you're like, you think this is hot, buddy? Just get ready.
Just you wait. So I've decided to start rewatching The Crown on Netflix. And even then, the 1950s and 1960s when Queen Elizabeth was, reigning and in the beginning of her reign, it was a very different climate. That 30-degree day in London would have been incredibly record-breaking, but now it's not so much. The climate has changed because of human emissions. But we can't, I guess just because we have a hot day, we can't directly, at least in that moment, attribute it to climate change. The baseline is changing and there are links, yes, but we shouldn't all be putting our hands up and say, just because we've had a cold day or a hot day, it is categorically due to climate change. There would be some influence, yes, but it's not a simple yes or no issue.
Nice. Got a Simpsons reference as well pretty early as well.
Yep.
There's an episode where Homer and his friend Barney get into a competition because they both buy snowplows to clear the snow away in winter.
Yes, I'm Mr. Snow.
And at the end, they join forces and they're like, if two friends work together, not even God himself can stop them. And then God's like, oh, really? And the weather clears, the sun comes out and all the snow melts. Well. And the newsreader, Kent Brockman, says something like, if, because it's in Fahrenheit, he's like, if 70-degree days are the price of climate change or global warming, then you'll forgive me for keeping my old Chevy. And it's like, if we still get cold weather, then surely there's no problem. That's like another misconception, right?
Yeah. Well, and this is the thing. We've seen this in Australia this winter. It's a little bit colder than what we've seen. Climate change mustn't be happening. That has started to pop up again. But I think we'll get to that a bit later on.
One of your people, someone in your network said, why has it been so cold this winter? Oh,
yes, Anthea. Yeah. So why has it been so cold?
Can I ask, is Anthea in Australia?
She is, yes.
She is. So I'm going to answer this one for you, and then you can tell me how I'm wrong. It's like it hasn't been that cold, Anthea. It's just that probably you live in a cold Australian house that doesn't have good windows and doesn't have good heating.
So that would be part of the response. But also there's...
Sorry, Anthea, it's Australian housing. But has it been a cold winter in Australia?
Well, not really. It's actually been fairly average. And again, it's important to remember how we measure our climate. We know it's changing. We know it's because of human emissions. But we have to measure our climate against some sort of baseline. So I talked earlier about at least a 20 to 30 year average. A lot of the time what we do to detect whether or not our climate is changing is keep that baseline the same. So for example, we might look at the average climate between 1961 to 1990 and say, well, that's our normal climate, whatever you define as normal, or the pre-industrial. It doesn't really matter what one. And then we see what's shifting around that, if anything, in the years following. If you compare our winter that we're almost finished here in Australia to a 1961 to 1990 winter, it was actually a little bit above average. So it wasn't actually that cold. However, when you compare it against recent times, it's maybe the coldest in the last decade. So, in the last 10 years. Yeah.
So it has been a cold winter for...
Let me fact check that, sorry. But it has been
No
colder relative to recent years for sure. But we have short-term memories. It's not just about what we've lived in. We have short-term memories as well.
Before you fact check that, and this maybe is a question not specifically for you as a climate scientist, but you may have heard this before as well. When it comes to Anthea saying, why have we had such a cold winter? Is there also recency bias? Not in terms of what things have been like in the last 10 years, but literally it's because we're in winter and you're like, oh, we've had a cold winter, you know?
I think there's a bit of that. So I've just fact checked it and we had the coldest start to winter in a decade. So June was very cold. I would vouch for that. We had 3 mornings in Canberra where it was like -7 degrees and far out. That was bloody cold and I hated every second of it. However, Canberra can also get to -10 in winter. That's not unprecedented. And we had -8s in August last year. So there is that sort of seasonal bias that you're talking about there. And we also came off the back of a really mild autumn and then suddenly winter slapped us in the face. We're all like, what's happening? What's happening? But it is winter.
Big job for you now. Probabilistic forecasting. Okay.
Oh, this is such a tricky one. Yeah.
Well, let's see how we go, right?
It says it's going to rain and it's like a 10%. Yeah. I'm like, no, that's not what it says.
Dongchi Lin says her dad used to be a forecaster and he constantly got questions from taxi drivers. This is not discrimination towards taxi drivers.
It's not just taxi drivers, it's everyone.
Why do the meteorology agencies always get the weather forecast wrong?
They don't.
Please discuss.
Discuss, right? How long do we have? This is an episode in itself, I think. It's the way that they present the information. And I'm not saying that they do it wrong. I'm not saying that they need to change that, but maybe they should think about different ways of communicating it.
You're not saying they do it wrong. But...
However, the thing is, it's probabilistic. What I mean by that is we assign the likelihood of that weather actually occurring. Is there a chance, yes or no? And how big is that chance, whether it's extreme temperatures or extreme rainfall or wind or whatever? It's not a categorical, it will rain today and it will rain by 10 millimetres, or the sun will definitely be out by 9 a.m. And the fog will have completely cleared by then. We can't do that. That's just simply not possible. So instead, what forecasters do and what we see now forecasts is, there's a 20% chance it may rain today. And if it does rain, it might rain between, 5 to 20 millimetres. Right? There's a range there. There's firstly a probability on whether or not the rain will occur. And secondly, a range as to how much might fall. I get that. Most people don't because of we assume that people understand probabilities.
But people are really looking for yes or no.
They are. And
Will it rain tomorrow?
But ultimately, how we forecast and how we communicate that forecast to the masses, it doesn't necessarily mix. So they don't get it wrong. If they say, well, there's a 20% chance of rain today, and it doesn't rain, well, they were actually right because there was only a small chance. That range that they give, whether it's between 5 to 25 millimetres, if it rained 10 millimetres, then they still got it right. It was within that range.
Maybe what needs to change is not that people need to understand probabilistic forecasting. Maybe it's that meteorologists need to accept that they will always be perceived as wrong. It's like at the end of The Dark Knight when Batman takes the blame for Harvey Dent killing people. And it's like he's the hero that Gotham needs right now, but not the hero it deserves. It's like maybe meteorologists are the heroes we need. And when people are like, took my umbrella out yesterday and it didn't even rain, they should be like, I'm so sorry, you're right. Gosh, we will do better, And they should have to accept that that's their fate, to always be wrong when they're not.
Now the meteorologists are going to come for you.
They're welcome to you. They already do. Moving swiftly on to something juicier, do clouds trap heat and can they affect warm weather?
So I'm really careful. I don't want to get this one wrong. Water vapor, which is what clouds are made up of, which is, water in the sky that's cooled and condensed and you get those big fluffy clouds. Water vapor is a greenhouse gas, so to say. It traps heat in when it's in its water vapor form. So when we have clouds closer to the surface of the earth. It's a bit different to carbon dioxide and other greenhouse gases because it's much more transient and there's only so much water we have in our system in the water cycle. So you can think about, and this happens a lot in Canberra. If we have clouds come through at night, our nighttime temperatures don't drop nearly as far as what they would. It happens a lot in winter. Like you can have one day where it's -10 and the next day it's like +3 because it's been cloudy at night.
Whereas if you have a clear sky at night, in the morning it's often colder because all the heat from the Earth's surface that it's absorbed during the day has then been radiated back out into space.
It's that long wave radiation. It's just been able to escape. The clouds haven't trapped it in, so it's just gone right back out.
So yes, what you're saying, correct me if I'm wrong, yes, sort of.
Yes,
like
sort
clouds
of, yeah.
will help to retain heat from the Earth's surface.
Exactly.
And they do also have a greenhouse gas function.
Yes, in the sense that they can trap heat close to the surface of the Earth.
It was a question from actually producer Zach's family and friends.
Yeah.
Do clouds trap heat and can they affect warm weather? Well, what's more likely to make it warm is the absence of clouds. Like if you don't have clouds during the daytime, then more of the sun's energy is hitting the Earth's surface, whether it's water or land, and heating it up.
I've taught you well, Iain.
Well, actually, I'm so sorry. This isn't you. This is Christian, our director, Christian Jakob, and some of his collaborators at Columbia University. Recently produced a really interesting paper about how the world's cloud cover has been reducing by between 1% and 3% each decade of the 21st century. So we've lost up to 9% of the world's cloud cover this century.
Yeah.
And that is probably very likely to be the cause or strongly linked to some of the record-breaking heat that we've experienced in 2023 and 2024 that you're so into.
A warmer atmosphere can hold more moisture. So it increases the amount of moisture the air can hold, increases by 7% each degree warmer we get. And that, whether that's a daytime change in, night versus day or over the course of 50 to 100 years, that relationship holds. So that can mean that we do have less clouds because the clouds aren't the water vapor is not condensing and forming and, we don't have clouds sitting there. That could be an explanation there. But it is important, like when we have hot weather, when we have extreme heat, it's the absence of cloud that is the issue because all of that incoming solar radiation is coming down. Also, as air descends in the atmosphere, it warms just by the physics of what's going on. And that's very problematic for heat waves. We very rarely, if ever, get extreme temperature when it is cloudy because the cloud during the day also blocks the incoming solar radiation, which can't be re-radiated back and to heat the atmosphere. And we don't have that warming air as it descends through the atmosphere as well.
The clouds are our friends.
They are our friends during the day, yes. And I guess they kind of tuck us in at night as well.
Maybe we should start a little group, Friends of the Clouds.
Friends of the Clouds, yeah.
I have a friend in the UK called Andrew.
Hi, Andrew.
Currently in the UK, there have been 13 days where the temperature was above 13 degrees this year. In 1995, which was a notorious or famous heat wave in the UK, there were 34. So is this climate change or is this semi-normal weather?
Now, 1995 does sound like it was exceptionally extreme for the UK. It's important to kind of think about what 1995 might have been like relative to the other years around that time, okay? 34 days. So it was 13 days so far this year. Even for parts of Australia, that's like a solid month of 30-degree days. That doesn't always happen every summer. So it's important to remember, again, what it was like at that time in that climate, and that would have been a very extreme season, likely a very dry one as well. We need to consider the long-term trend. That's what we talk about. It's not just one event. It's not just one intense tropical cyclone or one intense heat wave or one super hot season. It's how are these changing over time because there will always be a few events that stand out, but they're the extremes and we do expect them sometime. So the fact that the UK's only had 13 days above 30 degrees this year so far, well, how does that fit into the long-term trend? I can't answer that off the top of my head.
Well, it sounds to me like this year has been a little bit more normal.
Exactly.
Because 2022, 2023, there were really like big heat waves in the UK.
Well, I just saw a forecast maybe a couple of days ago where parts of England was going to reach 40 degrees. Okay, so we're still seeing...
And we've had a lot of, we don't know when this episode will go to air, but there are literal, fires in Spain at the moment.
Yes, and Edinburgh, like on Arthur's Seat. So it's not just about this one statistic as well. It's other statistics that we bring together to get a basic understanding. Looking at just one event or just one season in just one location does not give us the full picture. And as climate scientists, we are really aware of that. So that's why we tend to take a much broader view when we're trying to understand, well, what is climate change and what's more of just that, extreme event that we expect to see anyway.
So a natural segue from our weather questions to the first of our climate questions. People often have said to me, or I hear or I read, that what we've noticed is just natural variations in the Earth's climate. How can humans be responsible for these changes? Because, we've had ice ages before. Surely the Earth's climate just changes sometimes, right?
Well, so yes. I don't know if I should start this way by
Yes, but.
Yes, but. Okay, sure. There have been natural variations in the climate before. There is a lot of truth to that, of course. But it's more the fact that we know about greenhouse gases, and we've addressed this in an earlier episode. We need greenhouse gases in our atmosphere for our planet to be livable, right? They help keep the temperature at a certain level. But we know from our actions since the Industrial Revolution, we've been putting more of these greenhouse gases into the atmosphere, okay? And they've been trapping heat in the atmosphere. And we can track them, right? It's not just a matter of like, oh, CO2's gone up. Well, I wonder why that is. They have a slightly different signature in their chemical makeup, and we can track them. And that's why we know we're putting more of these greenhouse gases in the atmosphere. They're because of us, and they're increasing the temperature. This is not just a natural cycle where things have happened naturally and greenhouse gases have been emitted naturally, or there's been some sort of tectonic shift or shift in how the planet orbits around the sun. They're natural causes of climate change. What we're seeing today is not. We can trace it back to our activities very, very precisely.
And one of the best examples of that is in Hawaii. They've been measuring the atmosphere, like the carbon in the atmosphere, since the 50s.
Well, and even then, right, so that's the Keeling curve, and seeing how carbon dioxide fluctuates seasonally since the 1950s to 1960s. This measurement until recently was taken all the time.
And the long and short of that is, over that time, which is now, 70 years, 60 years, carbon in the atmosphere has been going up and the temperature has been going up.
Exactly. But even breaking it down to that, like, all right, well, there's more carbon in the atmosphere. Well, how do we know it's because of us? Again, because we can track it due to its chemical makeup at the atomic level. The signature of the carbon or carbon dioxide is a little bit different when humans emit it versus what comes from natural sources. And that's how we can also dig up a really long ice core from Antarctica or Greenland, and we can check what the chemicals in the ice was like hundreds of thousands of years ago and see how different it is from now too. Exactly. So these are all indicators to show us it's our problem. We're the problem, not a natural cycle. And on top of that, it's the rate of change as well. There have been rapid climate shifts in the past, and we can, again, use ice cores and other means to track what the past climate was and how quickly it shifted. But again, the cause and the rate at which it's happening is unprecedented and due to us, or unprecedented in, I think, at least the last million years, maybe even the last 5.
And you alluded to this, but let's name it explicitly. The Trump administration wants to shut down that observatory in Hawaii because they don't want us to know that we're causing climate change.
The mind baffles, really. Like, at least we have other ways of monitoring atmospheric carbon. We have a Cape Grim here in Australia that does the same thing. But why they want to get rid of it?
Well, they want to get rid of it because they don't want people to know. They want less evidence, less information so that they can continue polluting and making money and denying there's a problem.
Bloody ridiculous. It's...
ridiculous suggests kind of silly or amateur or whatever, but this is a very sort of deliberate suppression of information where people's lives will be lost and damaged because of it.
Well, and there's also a report that was released by the Department of Environment or Department of Energy, whatever DOE stands for in America, that is just damning and, saying climate change isn't really a problem, especially for the United States, but it's actually people are working on it and finding out that some of the references don't actually exist and some of the text has been written by ChatGPT. So there's a lot of giving out false information that's coming out now.
Let's ask a different question suggested by our colleague Hamadri, which is a question that she's heard before or a topic that people put to us. Does global warming mean it's getting warmer everywhere?
Yeah, this is a term that was used maybe 20 or 30 years ago more regularly. Like, we put more carbon in the atmosphere, it's going to heat up the atmosphere, right? So the globe will warm. But lately we use climate change more commonly because we now understand that the climate won't change the same everywhere. Now, we are seeing global average temperatures go up. So that's the average of all temperatures everywhere across the course of a year or so, and that's increasing. But that doesn't mean at every single location we'll see that exact change. So, for example, there are parts of the ocean where temperatures are declining, and that's particularly on the southern tip of Greenland. We're seeing that because all of the ice is melting and it's going into the ocean, which is therefore dropping the temperature locally.
Another example of how this can happen is if the North Atlantic current,
Yes.
the Atlantic meridional overturning circulation,
Yeah.
the North Atlantic current, the Gulf Stream, if that fails or weakens enough, then Northern Europe, Scandinavia, and the UK will become significantly colder than it is now.
Yeah.
Even in a world where in the rest of the world we've got higher temperatures and more heat waves, etc.
Exactly. So there's that localized effect. Again, climate is local, all right? It's based on the conditions at your location. So how global warming or climate change affect your local climate will differ. And not just in terms of whether it will warm or cool, but, when that might happen, how much that warming or cooling might be. There's a lot of different factors that influence that, not just the fact that on average the globe is warming because of human activity.
Also, a question or a topic that Himadri suggested, what's the difference between a forecast and a projection?
Oh, this is a good one. So forecasts are typically reserved for things like weather forecasts, and projections are typically reserved for when we're talking about long-term changes. So there's that difference in timescale. Forecasts are
weather forecast,
yes, and climate projection. Exactly. So climate is like 30 years, like an average over 30 years. And we usually use projections to think about climate change at least 20 years from now, but oftentimes 50 years, 100 years, 1,000 years from now. That's a projection. We have a larger range of what might happen. When it comes to forecasting, it's only like a scale of a week. I'm gonna like say maybe max 2 weeks, but honestly, you shouldn't trust a weather forecast more than 7 days out and often more than 5 days out. Let's just call it for what it is. Anything more than 7 days is not very reliable. It's much more precise. The timescale's smaller. And even in terms of local changes, like we get a forecast for different parts of Sydney because the local climates are different versus different parts of Melbourne, right? The scale is much more different. And it can also be much more precise, right? So we're talking about temperature changes during the day that won't fluctuate by that much compared to what's actually forecast. Projections, there's a larger range of what we could expect.
Great. Thank you. A question from my cousin Ruth in Scotland.
Oh, hello, Ruth.
Thanks for writing in.
Yes, thanks.
I think I also know the answer to, and it's not necessarily a very cheerful answer, is she had the perception that while a lot of people and countries bounce straight back to normal after COVID, some other people have changed their habits, like their travel habits or their consumer habits. So we saw a slight drop in emissions during COVID.
Yep.
Has that drop stayed the same?
Nope.
Has it gone down? Has it gone up?
It's gone up. I laugh because if I don't laugh, I'll cry.
You sicko.
I've shown this slide to my undergrads and, yes, there is a noticeable dip during the COVID lockdown, but we have by far overcome that dip on the upwards inflection on the other side. So, it was great to see that, if we do change our behaviours, we can reduce greenhouse gas emissions in a meaningful way. But that was only temporary, and we've since recovered any sort of change we had even just a few years ago.
While that's a little bit troubling to see, I also think it's quite instructive about the scale of the challenge we face.
Yes, exactly.
So, if in the last 150 years, the only year in which our emissions went down was 2020.
Yeah.
Right?
Yeah.
And what that took was a global health emergency where just about every country around the world, every individual and every government, local, state, federal, every industry, everyone agreed to do less.
Exactly.
To move less, to spend less, to travel less, to work less in some instances. That placed an enormous strain on society. There were many people, it was the hardest thing they'd been through.
Oh, yeah.
Everyone was desperate to leave their house, to get back to seeing their friends, to get back to holidays, to shopping, to what makes life go round.
Yeah.
And so what would be required to stop emitting and to reach net zero as rapidly as possible would be that scale of collective and individual sacrifice. And we saw how much pressure that put on society. People started buying into conspiracy theories more. People wanted to vote in hard right politicians who gave them easy answers about these problems. And so, yes, we could reach net zero tomorrow if we all agreed to completely stop. And I think that that's not only unrealistic, but potentially dangerous for, the impact it would have on our society.
I hear you. I agree with everything that you're saying. I struggle with why does it have to be that way? So yes, you're right. COVID, everything shut down. We stopped emitting. It was great to see that it could happen, but yes, under absolute dire circumstances, hard agree. But why do we have to do that to reduce our emissions? We have green energy solutions now. Yes, I know there's issues with accessibility, and I'm well aware of that. But there's technology available to help us reduce our emissions. It's just got to be rolled out at scale. That's all it's really taking. It doesn't have to be that dire for our emissions to go down.
Perfect segue to our next question, which is a talking point prompted by our colleague Aditya Sengupta, who says, are we too late to do something about climate change? What scope do we have for keeping our temperatures below 1.5 to 2 degrees, which, correct me if I'm wrong because you're the expert, but I'm learning fast, is all about how fast we get to net zero?
Yeah, look, yes, in a nutshell, yes. So are we too late to do something about climate change? It's never too late to do something about climate change. Let's just say that as it is, okay? But it may be too late to limit warming to certain amounts of warming. And I would say it is too late to limit warming to 1.5 degrees Celsius unless we take those drastic actions that we saw during COVID and keep them at that permanently and do more as well.
My kind of hard left, anarchist, vegan, queer friends cover your ears. Like as a centre left person, as a centrist, we showed during COVID it's possible, but it's not sustainable.
It is not sustainable.
People will go
Not
crazy.
now.
They will rebel. They will vote the government out, and they will vote in people who tell them they don't have to do this.
Exactly. We can't feasibly do that. Like you might hear some people say, oh, yes, it's still physically possible. It's just going to take a whole lot of money and technology and time. It pains me to say this. It really does. That ship has well and truly sailed. We had our first year last year where global temperatures, went above 1.5 degrees Celsius for that year. And that's a strong indicator that we're going to sit at that when we look at the long terms over the next couple of decades. Like as a climate scientist, that's heartbreaking, but it is what it is. However, it doesn't mean that we should say, well, we're done for now. Climate change, we just got to give up and it's too late to do something about it. It is not. Fine, we have reached 1.5 degrees Celsius more than likely. What can we do? What can we limit now? Can we limit warming to below 2 degrees Celsius? And there's still a little bit more hope that that's the case, but current, knowledge indicates that we're still going to overshoot 2 degrees Celsius. But we've got a much better chance at limiting global warming below 3 degrees Celsius. I mean, that's extremely likely at the moment. There's more we can always do, but it's never too late to do nothing, if that makes sense.
Can we keep it to 2 degrees of warming, or is that also unrealistic now?
It'll be very hard to do that. And that's my educated view. Some people may come at me who are, into carbon accounting and may say, oh, no, we can do it. It's still possible. But again, like going back to what you said, Ian, like let's think about what's feasible in the world view and how people will cope and rebel, like given how harsh some of these changes will ultimately be.
How many people do you know who are into carbon accounting and why are you hanging out with them?
Well, it's part of my job. Right? The UN Secretary General has still put out statements saying this, like it's not too late to limit to 1.5 to 2 degrees Celsius. There's still a bit of hope there, but that hope is unfortunately rapidly decreasing.
My favourite piece of recent UN content is the UN put out a report about how no one reads their report.
Oh my
Did
God,
you see
really?
that?
Oh, that's hilarious. No, because I don't read their report.
I put it in our group chat at work. So not only did no one read their reports, no one read their report about no one reading their report.
Personally, I don't think we have much scope to limit warming to 2 degrees Celsius. And this is based on current commitments of international nations to reach net zero and by when. If all countries follow their pledges, we'll limit warming between 2.7 to 3 degrees Celsius currently. That's not to say we can't.
We need a slogan like stay alive at 2.5,
Oh, Jesus Christ, God, that doesn't.
What about that? That sounds good, doesn't it?
Can we have a little bit more optimism? Like, okay, we've got the stay alive there, but at 2.5.
There's a lot to do for 2.2. Or fuck me, we're headed for 3.
That's it. Fuck me, yeah.
UN would get more downloads if they hired me, I tell you what. Can you tell us about what net zero means and what overshoot means, please?
Yeah. And I think, net zero is a term that we've also heard a lot about in the zeitgeist over the last few years. So net zero is basically indicating that we're not, over the course of a year or a certain time frame, we're not putting any more carbon into the atmosphere than what's already there. Okay, so we may be emitting something, but then we're also using technology or resources to remove that something, or we're just, completely not emitting any more carbon at all whatsoever. So it can happen in those two different ways. Over that course of that time period, there's no extra carbon going into the atmosphere. Whereas overshoot is, let's just we'll continue pumping for a while and then we're going to suck that carbon out. So we've overshot or overshooted, whatever the right
Overshot, I think.
Overshot that threshold. Maybe it's 1.5 or 2 degrees Celsius. And then we suck the carbon out of the atmosphere, and that then apparently speaking, will bring the temperature down. So we go over the limit but then we kind of come back under it through using technological means to bring that carbon out.
Is that carbon capture and storage?
That's one way. Another way is apparently covering the world in trees again. They're the two main ways, I would say, but there's issues around that as well, assuming that the technology and, the amount of tree planting we can do will actually be feasible.
Bit of an Achilles heel to planting trees as well, isn't it?
Well, that's it. Like they may be cut down or they may be burnt down, and then the carbon just goes straight back into the atmosphere.
But if they burn, and we're having a lot of wildfires all over the world at the moment. I think we had some really bad forest fires in Canada in the last couple of years.
Yes, almost every year, last 5 years. Yep.
And I think I read that the amount of carbon that got released into the atmosphere during those Canadian forest fires was the equivalent to a reasonably sized country's entire year of emissions through industry and transport and that kind of thing.
There's even been years in Australia, like Black Summer emissions, like I can't remember off the top of my head, but they were comparable, to like other...
To a whole country of industry and planes and trains and cars.
Absolutely.
And we should just be prepared that if we plant loads more trees, which we should, in a hotter world, there are more risk of burning down.
Exactly. And like the whole idea of net zero is great in its concept, and we need that. Like we need to aim to not emit any more carbon, but we should be doing real net zero, which is when we're really not emitting, as opposed to playing around with the numbers, like reducing our emissions a bit, sure, but also just playing around with the numbers.
This one comes from your friend Jakob.
Jacob, yep.
Can we expect global temperatures to decrease if we manage to reduce global emissions to zero?
This is such a good question, and it's so novel. We're only just starting to grasp that by using projections from climate models. So looking into the future, assuming that we reach net zero or emitting zero emissions by some point in time. And look, honestly, we don't have a great idea as to whether that will happen in 50 years from now or 100 or 200 years or even 1,000 years, whether or not global temperatures will go down. So some simulations that have been done with Australia's climate model are showing that global average temperatures don't actually go down. They don't necessarily increase by that much over 1,000 years, but they don't go down. And that's really concerning. That was a real eye-opener for a lot of us. There are, however, some different types of climate model simulations that say that there will be a reduction in global temperatures in maybe 100 to 200 years. So ultimately what that tells us is it ultimately depends on our actions and also how the climate system responds.
But what it also means, and this is not very inspirational, I'm afraid, so brace yourselves, folks, but what it means is we have to reduce our emissions to protect the Earth system, but you and I and your children and their children and their children's children will not feel the benefits of that. Like the burning of carbon over the last 200 years has locked in changes that we will be coping with for hundreds of years, if not millennia.
And that is the most unfair thing about it all. We're fucking things up big time for future generations that we can't even imagine yet. And yeah, it makes it really rough.
Do you remember Lord of the Rings, Sarah?
Oh, I didn't really pay a lot of attention.
Near the end of Return of the King, they've saved Gondor from Sauron's army, but he's got lots more armies, and they need to try and buy Sam and Frodo some time to get to Mount Doom and throw the ring in.
Okay, I do remember that bit, yes.
So they take what's left of their army and they march on Mordor to scare Sauron, even though they don't have an army big enough to defeat him. And in the books, quite explicitly, Gandalf says, we'll probably all die, and we may not even enjoy, if Frodo then destroys the ring and Sauron is defeated, we won't be there to enjoy it. And it's like we are that version of Aragorn and Gandalf and the armies of Gondor and Rohan marching to our doom to try and save the world for the people who come after us.
Kind of, yeah. That's the thing. We're not even really marching to our doom because we're not going to be here to experience the worst of it. We're putting our kids and our kids' kids and blah, blah, blah into the firing line. We need to make
sacrifices now.
Yep.
What we're talking about is, I like history a lot, and I'm thinking about, what life was like in not even medieval Europe, but like Dark Ages Europe, like 800 AD, Anglo-Saxons, like we're now 1,000 years, 1,200 years after them. Those are the people who will benefit from us stopping emitting carbon now. And I think that's another reason why it's so hard to get your head around and why it's so hard for people to to make these changes is because it's not even your kids that will benefit. It's thousands of years from now, a different civilization.
Our kids will see the worst of it by far.
I'm thinking of Andrew King's research.
Yes,
So our
yeah.
colleague Andrew King at the University of Melbourne is a specialist on projections of net zero futures and how different the climate and the world will be depending on how fast we reach net zero.
Yes, yeah.
And maybe a more optimistic outlook is that, the sooner we reach it, the better.
Yeah, hard
And
agree.
the sooner we reach it, some places do see a stabilization of temperatures, right?
Yeah.
And some places don't.
Yes, correct. Yeah, that's right. But that depends what happens locally. Like, so within those simulations, it's the continual warming of the Southern Ocean that is very likely driving continual temperature increases in the Southern Hemisphere.
Yeah, Southern Ocean's in the naughty corner because this, like, even when we reach net zero very rapidly and, the Southern Ocean continues to warm for a long time.
It just warms less if we get to net zero sooner, right?
Yeah.
Whereas the Northern Hemispheres, a lot of those regions will start to show an eventual temperature decline. But this is the thing. This is one set of climate simulations that are showing that the Southern Ocean will continue to heat up. And there is a physical understanding and basis for that. Whereas other climate simulations don't necessarily have that. So that's why we're like, well, how is the Southern Ocean going to respond? We don't really know. And the only way we're going to know is when we get there.
To take Jacob's question literally, can we expect global temperatures to decrease if we manage to reduce global emissions to zero? Yes,
But
eventually.
Eventually, yeah.
Eventually.
Whatever eventually is. But yeah.
My friend Andrew says, is there any way of reversing the melt of the ice caps if climate change happens soon?
No.
No.
Well, I'm not a polar expert. However, it's like a runaway effect, right? Once this process starts, it's very difficult to slow down. The more carbon, the faster this will happen, the more melting that happens, the more difficult it is, again, to slow down. It will eventually slow down at some point, but we're talking thousands of years.
And in terms of, topping those glaciers up, topping those ice sheets up, let's say we reach net zero in 50 years, which would be cool. We're going to lose a lot of ice.
In 50 years, absolutely, we'll have lost most of it.
We might get some ice back in, are we talking hundreds of thousands of years for ice caps to be topped
That's a
up
good
again?
question. I'm not sure.
I'm afraid we're speculating now.
Yeah. I would have thought thousands to tens of thousands, but it also depends what the planetary orbit is doing as well. That affects how ice caps change too, and that's something we don't have control over.
So you could argue that ice caps. When we say ice caps, we mean like the fresh water that's frozen on top of
land,
Antarctica in particular. That is one of the longest kind of like long run impact.
Well, that's it. Yeah, it takes time. So I remember narrowly saying when we interviewed her about Antarctica that for all the ice to melt, we'd have to put temperatures at, 10 degrees for thousands of years?
That's actually worth pointing out, isn't it? So maybe people have a perception when we hear about the ice caps melting, maybe people think that the Antarctic will be completely, without ice in their lifetime. That's not going to happen.
No, that's not going to happen.
A troubling amount of ice is going to melt into the sea, but Antarctica's still going to look pretty Antarctic-y.
Yeah, it's still going to be icy. It's just not going to be as icy. It's just that little bit of change, relatively speaking, to Antarctica does mean a lot for sea level rise in other parts of the world.
More at risk and more immediately are glaciers.
Yes, glaciers, sea ice.
Alpine glaciers in particular. My mum asked about glaciers in the Swiss Alps.
Yeah. God, yeah.
Which we saw on holiday when we were younger. And my friend Alex and I were in New Zealand recently at the Fox Glacier and the Franz Josef Glacier, and they are going.
So about 10 years ago, my husband and I were doing a hike with friends in Switzerland. We were backpacking at the time, but it was
slumming it in Switzerland.
Anyway, it was a wedding present. They couldn't make it to Australia for our wedding, so they took us on this beautiful hike. It was like I reflect on this regularly. But anyway, we got to this bit and they had this enormous suspension bridge, and I'm sure you can imagine what I was like. I freaked the fuck out that I had to walk over this enormous bridge. And they said that was the first time, because they'd done that hike many times before, but the first time they'd come across that particular bridge. And they read a sign that was in Swiss German, and it said they had to build a new bridge because of how rapidly the glacier was changing.
Wow. And
that was an eye-opener even to, and that one of them was a climate scientist, so it was an eye-opener to them. Like, we slept next to the glacier in one of these gorgeous Swiss huts, and you could hear it cracking and moving in the meltwater. And the people staying or who run that were saying that, that was happening more than what it used to. So, like this, and that was 10 years ago. This is, a long time ago. So there's been more retreats since then. And, there's a lot of indications that in some areas they'll be glacier free. There's also sea ice in the Arctic and how that's going to change, and having ice-free summers completely in those parts of the world. That's a reality. That's a reality dependent on when we reach net zero emissions. So those sorts of amounts of ice, yes, they will likely disappear, but not all of the ice everywhere.
Well, here's one for you then. A question from Alex's visit to the school. Something that came up was the perception from young people, so teenagers, that climate change won't impact them, that it's something far off. And this is how I used to think when I was a teenager.
And this is what we've just spoken about this. Like, the worst is yet to come.
So what you're saying is you and I are okay.
But we're not, no. Like, climate change is happening now. Like, we've seen these changes, we can detect these changes, and we know it's because of human emissions. The world that we live in now in terms of temperature and climate is very different to what it was 50, 100, 200 years ago. So it's not a future problem. It's very much a now problem. It's just that what we perceive as normal has changed.
So it's quite different from 50 years ago. What will it be like 50 years from now when you and I are retired? I mean, retirement won't be a thing. That's
50
the first
years
problem.
from now.
But, when we're in our 70s and still working.
I'll be dead. Well, okay, so we have seen a lot of change in the last 50 years, but we're expecting even more change in the next 50 years. So that rate of change, the speed of change is actually increasing as well. So we've warmed, give or take, 1-ish degree, maybe a bit more in the last 50 years. In the next 50 years, we'll probably warm by probably 2 degrees. Or so, again, give or take, that's a rough estimate. So that's double the rate of change. And with that will be more extremes, higher impacts. And yeah, it's speeding up. Not only are the changes going to be worse, but they're speeding up.
More heat waves, more flooding, heavier rain, stronger storms.
Exactly. All like the whole shebang.
Yep.
I guess maybe for the benefit of the doubt, maybe it is a future problem in that way because there's worse coming. And we're like, I'm drawing a long bow here, but we're kind of okay now. But it is, the health of the planet is much worse than what it was 50, 100 years ago. And that's, it's not a future problem. It's very much a now problem. And on top of that, the actions we do now matter for the future. So that's what we need to keep in mind. I know it's a very hard concept for most people to understand day to day or grasp day to day and put in their daily lives. But it is so very important that what happens now matters in 50 years and 100 years.
Another thing that came up during this visit to a school was the question of sustainability, like recycling, and climate action. Are they the same thing?
They're related. So climate change can be perceived as a type of sustainability or sustainable way of living, but it's not the only sustainable action that we can do. If we undertake drastic climate action, we're making the planet more sustainable. We're making our climate more sustainable. We can live in a sustainable way when we're referring to our climate. But there are other actions that we need to undertake to make sure our lives are sustainable more generally. Recycling is one of that. So we're not using materials and throwing them out after a single use. We're getting the most out of them and therefore protecting our planet at the same time. So recycling alone won't solve climate change, far from it. It's, that link there is a little bit tenuous as well. Like just by putting things in our yellow bin at home doesn't mean we've reduced our emissions by really that much at all, if anything. But they're both actions or they're both ways to have a sustainable future.
Okay. I had a question sent to me by my colleague Nick, who is at the University of Melbourne, and he says, can we learn anything from history about the impact on society of the temperature change we are likely to experience in the next 50 years? E.g., has there been any relevant major weather or climate events in recorded history, and what impact did they have?
Yeah, so this is something we actually call climate analogues, where we can use events of the past to understand how we may respond in the future. It is important to remember that the events of the future will be worse than the events of the past, but we can learn a lot because it is the human condition to really only adapt to the last worst event, if at all. So we really find it hard to adapt to events that haven't yet happened at extremities that we haven't yet experienced. It's just not something we're good at. We need to have that foresight, but we, generally speaking, we struggle with that. However, there has been really bad events in the past that have caught us somewhat unawares and had really bad impacts that make us think, well, all right, well, what do we need to do to negate these impacts in the future? And the first example that comes to my mind is the European heatwave of 2003. So at 20-odd years ago, more than 20-odd years ago, this event was off the charts. It was really warm and 70,000 people died. It was the hottest summer on record at that time.
That is a huge death toll.
70,000, yes. It's enormous. Most of that was in France and continental Europe, but there were some deaths in the southern UK as well. And it caught people off guard, right? The temperatures that were experienced, and I can't remember what they were in absolute terms now, but were like by far above normal. They were very, very extreme and also not what we would typically expect for that climate. So people didn't know what to do. People didn't know how to behave. I'm sure you can speak from your own experience, Iain, that the buildings there are not designed to keep people cool. It's to keep people warm. There's no air conditioning. There's no behavioural understanding of what to do during a heat wave, which, in Australia, I would argue quite strongly that we do a better job here. So that, enormous death toll, a lot of these people were actually elderly. They lived by themselves. They didn't know what to do. Some of them would have been cognitively impaired. The older you get, the less likely you're able to sweat, which is an important mechanism in keeping cool. Also, people not checking up on them. So there's all of these factors, not just the fact it was hot, but all these factors feeding into that huge death toll.
Even something as simple as a lack of awareness about hydration.
Exactly, yeah.
I don't actually have evidence or data to substantiate this, folks. Sorry, it's more my supposition. But I have a perception that that generation, so people who are our grandparents' age, Sarah, my grandparents
mine would be
away,
over 100. But yeah.
People who at that time would have been in their 70s, 80s and 90s, certainly in the UK, they are not as... they're not carrying a water bottle around that tells you how much you should drink each day. It's a very millennial thing, right?
Absolutely. And even as kids, I don't recall us typically walking around with water bottles.
No, we just drink when you're thirsty, and then otherwise you just running around.
Now we're so much more understanding about hydration and, keeping ourselves, hydrated. So yeah, so there was all these factors and, more than 2 decades on from that, there have been, I don't know how many exactly, but European summers, quite a lot of them have been warmer than that particular summer. We have seen heat waves that, climatologically speaking, are far more extreme than that 2003 heat wave with that enormous death toll. But less people have died. Because we've looked at that and go, all right, well, temperatures are going to be worse. Climate change is happening. Heat waves in that part of the world are warming twice as fast as global average temperatures are warming. What do we need to do? Right, we need to warn people. We need to educate people. Not sure if they're building better houses. We need greener areas. There are adaptation procedures that we can do to negate those impacts. So absolutely, yes, we can look at events of the past, look at their impacts and try and safeguard ourselves against them in the future.
Your point about are they building better houses? No. There was a really interesting article in The Guardian this week about high-rise flats in London becoming, if not unlivable, then very uncomfortable. Like new builds that are, obviously designed to keep the cold weather out, but are terrible for the summer. Where, someone was quoted in this saying that their apartment in London was 28 degrees or above for months on end this year.
Yeah.
They don't have fans built in.
Yeah.
So,
and the airflow is important too.
And that is going to become an increasing problem in Northern Europe. In Southern Europe, obviously it will get hotter, but in, Spain, Southern France, Italy, the Mediterranean, there is an awareness about
more
keeping
so.
cool.
Yeah, definitely.
There's more sort of institutional knowledge about that, whereas in Britain, for example, and I don't know, maybe Scandinavia, Netherlands, Germany, not as much awareness of that.
Well, it's just not embedded into the culture.
A question from Zach's friends and family.
Oh, yep.
If there is so much uncertainty in the data, how can we be confident that climate change will have the negative results that are being proposed?
Your family has all the good questions, Zach.
I mean, maybe we should zoom in on the word uncertainty and what that means in the context of climate modelling.
And see, this is hard. I hate this term so much, but we use it so often and it does not translate from the climate science to the general population. So uncertainty somewhat refers to the variability we have around what can be expected, okay? So we know the planet is going to warm and it is warming because of human emissions. We know that. That is certain, that is unequivocal. I cannot stress that enough. But we don't know exactly how much the planet will warm by the end of the century because there's other factors that come into play that we don't have control over, right? Like population, when we reach net zero, all that sort of stuff. So that's where the uncertainty comes from. We know a change is going to happen, but we don't have the precision by how much that change will happen.
And am I right in thinking we have lots of different climate models around the world?
Yes.
That function in slightly different ways.
Exactly.
They have different inputs.
They're like different siblings of the same family. They're just a little bit different.
And slightly different inputs produce slightly different data.
Exactly.
So
and they all go in that range. Like they're all most of them are just as valid as the next. So we don't say we're going to choose that one or that one or that one because that's problematic in itself. We look at at the range. And that level of range is what we term the uncertainty when we look at climate projections.
It's different. So there's lots of outcomes. They're broadly similar,
Yeah.
but there are slight differences in all the predicted outcomes. That's the uncertainty.
It's just the range that and some climate entities have a higher range than others. Extreme rainfall might do over some regions will have a larger range, and there's physical reasons because of that. We have a smaller range when we're talking about temperature change because that's much better understood. There is still a range. And again, unfortunately, there's that communication issue there that we term it uncertainty when it's really not. It's a range.
Okay, thank you. I have a question from my friend Hugh, who says, it feels like climate change is here to stay, in all honesty. I quite like that phrasing. It's like, yes, it is.
Yep. Done. Next. Thanks, Hugh.
It's
Thanks
here.
for coming.
It's not going anywhere. And the only thing we can do is slow it down. I agree.
Yep.
I agree with you, Hugh. Until the big players change their habits, China, USA, India, etc., is there any benefit to smaller nations making big changes?
So I would say yes. And maybe this is, being, an optimist in this point of view, right? That even those that are emitting relatively small emissions are making long-term beneficial change. Maybe developing technologies that can be produced at scale for other locations. Behavioural change as well. It all counts. It all matters. As the IPCC, or the Intergovernmental Panel on Climate Change, says, every tonne of carbon dioxide in the atmosphere matters. So every tonne we can stop going into the atmosphere matters, even if it's a smaller country or smaller player putting that in, even if it's a single fossil fuel project putting that in. It all matters and counts.
And Hugh's a smart guy, so he's got a segue ready with his second part of his question. Which countries are most under threat from severe weather? And will we see mass population displacement as a result? I imagine you're going to say that climate change and high impact weather is unfair and unequal, and it's countries around the equator, less developed economically countries are the ones that are going to feel the brunt of this.
Yep, you basically answered the question. Yes. So when you think about sea level rise, it's the low-lying islands that are going to be most affected, in part because they are low-lying, but in part because they have low adaptive capacity, whether that's because they can't retreat or they don't have the resources to do so. Okay, and then we think about the places close to the equator, which are the hottest and the most humid. So when you have heat and humidity combined, it is very lethal. They're already starting to see events that are pushing the realms of what humans can actually cope with. They will be, again, because of not just the baseline climate, but because of their adaptive capacity, will also be most affected. And these are the places that are either too small, be putting so much carbon dioxide in the atmosphere, or don't have the means to do so. And unfortunately, they are the ones that will be the most impacted.
Places like India, Bangladesh, Pakistan are not only highly vulnerable to the impacts of a changing climate, but there's a reason why they're less economically developed and more vulnerable than Western Europe, and Britain in particular, is because of, colonial exploitation.
So I think, and so on this conversation as well, it's not just these countries that will be most affected. It's also minority populations within even developed countries. Those that don't have the adaptive capacity to cope or the resources to do so, they will be most affected by the impacts of climate change, which is just it's not even ironic. It's just really sad that it's that way.
The natural transitions continue to thinking about impact on people and vulnerable people. Your friend Em Ramsey, who I think is a midwife.
She is, yes.
Says the WHO, that's the World Health Organization, has discussed the impact of climate change on pregnant women and young children. Are you aware of any Australian studies looking at this, particularly the role of extreme weather in birth outcome? This is you and your group's kind of wheelhouse, isn't it, Sarah?
So, there's research happening at the University of Sydney that are researching how people cope when temperatures are extreme. And they do research and experiments, for want of a better word, on pregnant people as well. So to see how core temperature changes when you're exerted to extreme temperature conditions. So there is research definitely going on.
Always in a safe and controlled way.
Always in a safe and controlled lab-based environment, and they never get to the limit of the actual real limit. They have
no pregnant women were harmed
that.
In the making of this science.
Exactly. But yeah, there are studies in other parts of the world that are more longitudinal. So let's look at the birth rate or the birth outcomes, and then let's track it back against temperature, exposure, that sort of thing, and different measures of that. I actually couldn't find anything for Australia, and I've actually put a literature review that touched on this together a while ago, and there wasn't anything specifically for Australia, but there are certainly studies pointing to that and showing this. So, premature birth, low birth weight, they're all recorded instances of exposure to extreme temperature and to extreme heat.
I have a question from my friend Michael back in the UK. He says, are extreme weather events finally changing public opinion, or are we still stuck in climate denial and apathy?
I wouldn't say denial. I don't think we're there anymore. Maybe a bit of apathy. No, not maybe. Definitely a bit of apathy in places. But it does take these enormous and detrimental extreme events for people to start the conversation again, or, for change to actually happen. One example I can think of is Black Summer here in Australia. And that really put climate change on the map here. Like, there were discussions around it, sure. But it was abhorrent. And people were like, oh, wow, this is what we've been talking about. Unfortunately, it didn't get too much traction because then COVID happened, and that was, literally a medical emergency. But it's events like these that get the conversation going again and, can kind of tell us, well, yeah, like these changes are happening now. We need to do more. So I do think they help, but they're not helping enough, if that makes sense.
So I said that was our last question, but I lied. There's actually like a couple of things that I want to wrap up with. And one is an overall question that's kind of come in from various people. Are we really totally cooked?
I'm sure everyone wants me to say no.
Bum, bum, bum.
I know, we're not totally cooked. No, I'll leave it there.
Slightly cooked.
We're a bit cooked, and we've talked about
Parboiled.
Soft boiled. But no, we're not totally cooked. Not yet. And yeah, we never will be.
What can the average person do to help? What are the practical steps that households and families can do to mitigate some of these challenges?
So my advice is to start small, work it into your routine, and then once that's set in stone, then go for the next step up. So this may be as simple as turning off more light, okay? Once you've got that in your bag, think about, can we maybe put solar on our roof? I know this is something that's not transferable to everyone, but that's another step, thinking about saving towards that, putting that on, maybe thinking about putting a battery. It's the long-term planning, the long-term doing this and starting small that I think is really important, because it is such a big problem. We're not expecting everyone to, switch off all their lights tomorrow and have mass solar rigs that could do the whole suburb. It's about starting small, doing things that are practical and that you can do feasibly, and then working up from there. But on top of that, another really important one is voting wisely, particularly here in Australia, where we all have to vote. Look at the policies around climate change. Make it known that you want better policies for you and your kids. Make noise about it. And then we are much more likely to have more resources available so we can all reduce our emissions much more easily, freely and cheaply.
No one should ever have the big light on. Have like a side light on.
Actually, this is what we do at home. If we're watching TV at night, the big light's off and we have lamps
my big
on.
light isn't. I may as well have it taken out. There is no big light. I hate the big light.
I don't like the big light either.
I think if you meet someone who doesn't really think about it or is quite happy having the big light on, that's a red flag.
Yeah, I would agree. It's actually really offensive just to be sitting there late at night with this huge light in your face. But apart from that, it will help reduce your carbon emissions. That's it for our first mailbag special.
We really enjoyed reading and responding to your interesting and thoughtful questions.
If you didn't get an answer to your question this time, please stay tuned for future Q&A episodes.
There's still plenty of myths to debug. Are carbon credits and offsetting really effective?
How do we talk about climate change to our kids?
For the answers to those questions and plenty more, join us for the next episode of Totally Cooked.
And we'll tackle the climate crisis together.